graphical features and terminology. That's our lesson for today. So there's a lot of terminology when we're talking about the graphs of functions, and many of those words or vocab words are very descriptive, but we still need to have those in our brain in order to describe any particular graph. So I have this function here to the right, that y equals f of x. So I don't know what the equation is specifically of that curve, but I do know that it's graphed over this interval. So it goes from -7, okay, to a +7. So that's our domain. It says find the maximum and minimum values of the function. So two very descriptive words. State the values of x where they occur as well. So our maximum value is our highest point here. So our maximum is going to occur at x equals and y equals what? So the y is what we're most concerned with because it's the high point. The higher the low is going to be our minimum. So we're looking at 1, 2, 3, 4, 5, 6, 7. Okay, so our max occurs at y is 7, and then the x that goes with that is -1. Then the minimum, okay, or our lowest point on this graph, down here, okay, there's our lowest point. So what is that y value that occurs at? And that occurs at y equals -1, and the x that goes with that, to make it a point, would be 1, 2, 3, 4, -5. Okay, so max and min values. Another piece that we need to consider, the y-intercept of the function. So the y-intercept, just like you learned last year, is where the graph crosses the y-axis. Oops. Sorry, it seems to be moving, and I just lost, there we are, lost my stylus there for a second. The y-axis, okay, of the function. Explain why a function cannot have more than one y-intercept. So when I look over here, that's where the graph crosses the y-axis, so that y-intercept is at 1, 2, 3, 4, 5, 6 is my y-intercept. Y equals 6. Why can't it have more than one y-intercept? Okay, so then it wouldn't be a function anymore. Okay, it would violate that function definition. Okay, or considering the graph, it wouldn't pass the vertical line test. Now, part C talks about another part of the graph. Give the x-intercepts. So the x-intercepts are where the graph crosses the x-axis. So I can read that graph. These are also known as the function's zeros. So those two are synonyms. X-intercept and zeros are synonyms. They mean the same thing because they are where f of x equals 0. So where does this graph cross the x-axis? I see two places, and only two places. So we could say that what are those x locations? So this first one here is x equals -6, and we also have x equals -4. Okay. So two x-intercepts. And it says, would you characterize the function as increasing or decreasing on the domain interval from -5 to -1. So I only want to examine that chunk of the graph. So from -5 to -1, domain x's. Make sure we're focusing in on the x's. So from -5, 1, 2, 3, 4, 5. So from here to -1 to here. So where I drew those two black lines, okay, in between. Would you characterize this? Now we read from left to right, so that's exactly how we're going to read our graph. What I just highlighted, would you consider that increasing or decreasing? Hopefully you're saying to yourself that is definitely increasing. Okay. And then to explain that, Okay, we would say because the x values increase, the y values increase. Okay, or it looks like it's going uphill. Okay, but a little more mathematical as x values increase, the y values increase. Letter E, it says one additional interval over which the function is increasing and one over which the function is decreasing. So let's look at our graph and let's find one other piece of it where it's increasing, where it looks like it's going uphill. So I think I might pick this here. So what is that interval? So that goes from 2, which is less than or equal to x, which is less than or equal to 5. Or you could write it in interval notation. You could say 2 comma 5 bracket. And then where is it decreasing? Okay, or where does it look like it's going downhill? I think I might pick this right in there. So where is it decreasing? So I would say from -1 is less than or equal to x, which is less than or equal to 2. And if I wanted to put that in interval notation, okay, -1 comma 2 bracket. Okay, and then let's look at part F. It says the following points are known as turning points. Okay, that's pretty descriptive. Okay, it's a point where the graph turns. Okay, each can be classified as a relative max or a relative min. Okay, so when I look at, this is sort of a, we're going to choose. So if I look at -5, -1. So -5, -5, -1, right there. Okay, is that a minimum point or a maximum point? Okay, and that is definitely a relative min. Okay, -1/7. So -1/7 up here is considered a relative max. It's a high point. What about 2, 2? So 2, 2, that point right there. Okay, that's going to be a relative min. Relative minimum. I tend to abbreviate that word. 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That point right there. And that one is going to be a high point. So that is going to be a relative max. Okay. All right. Let me go ahead and we turn the page. All right. So you guys are going to complete this back page, okay, on your own, and come to class with it done, but I'm going to give you some hints here, okay? So what do you need to consider here, okay? So this is a piecewise function, and we have our two pieces. We have our two intervals there. Need to be cognizant of that. Be careful. Here are x values. You're going to do your calculation, and then you're going to come up with your point. You're going to graph it over that interval. Then the zeros of the function. The zeros are the x-intercepts, okay, that we talked about on the front page. State the function's y-intercept. You guys know where the graph crosses the y-axis. Pick the intervals where it's increasing and decreasing. Give the coordinates of one turning point, and then tell me, is it a relative max or a relative min? And then it says, use your graph to find all solutions to the equation f of x equals 2. So you're looking for x values, okay, all x values, I'm going to put a question mark there, where the y is 2, f of x is 2. So you're looking for all inputs that give you an output of 2. It says illustrate your solution graphically and find evidence on your table. So you're looking for it on your graph and then mark it on your table as well. And then this last piece, state the interval over which the function is positive. Okay, I'm going to make you think about that one. Okay? How can you tell this quickly from the graph? Or the interval over which the function is positive. I want you to think about where it's above the x-axis. Above the x